Hello everyone, welcome to AKECE channel. Today we will discuss about time division multiplexing, very important 8-mark topic. Let's start the topic. So you are all familiar that PAM refers to pulse amplitude modulation. So here PAM means pulse amplitude modulation. One of the main feature of PAM technique is conservation of time. So how it gets the feature of conservation of time? Because it follows the concept of time division multiplexing. That is, for a given message signal, you are having one message signal, that message signal will be converted into a PAM waveform. That PAM waveform will have pulses with amplitudes varying according to the message signal. So that pulses are transmitted in your communication channel only for the fraction of sampling interval on a periodic basis. So your given message signal is converted into a PAM waveform which is having several pulses, and that engages the communication channel. That is, they are transmitted in the communication channel only for the fraction of sampling interval. Okay, you are all familiar with the concept of sampling. Okay, if not, you just revise the topic. And the time interval between adjacent pulses of the PAM waveform. So your PAM pulses are transmitted on sampling interval basis. So between the adjacent pulses, first pulse will be transmitted. After the sampling interval, you will transmit the second pulse. So in between some time spacing is there, right? The time interval between adjacent pulses of the PAM waveform. So that time interval is utilized by another one message signal. The sample of another message signal is placed in between the samples of the current message signal. In this manner, the common communication channel is utilized for transmitting several messages. Okay, so all these are occupied on the time basis. Therefore, this technique is called time division multiplexing system. So this facilitates joint utilization of a common channel without mutual interference. You are having a message signal, you are converting into a PAM waveform which is having several pulses, and according to the sampling theorem, the signal is sampled and then it is transmitted. Okay, between one pulse and another pulse there is a sampling interval. Between this pulse, the PAM waveform of another one message is transmitted. Okay, now we will go for the block diagram of TDM system. It has several components which are shown here. Now directly we will go to the diagram and we will discuss. This is the TDM system block diagram. So it has several components. Here you are having the message inputs. Message input 1, 2 up to n number of messages you are providing. Next it is having the low pass filter. These filters are called pre-alias filters. After that you are having a commutator, pulse amplitude modulator, communication channel, pulse amplitude demodulator, decommutator, and then again at the receiver side you are having low pass filters which are called reconstruction filters. Okay, here timing pulses are provided for your PAM modulator and demodulator, and this commutator and decommutator are synchronized. Okay, so this is the block diagram representation of your TDM system. To explain this concept clearly, you must be familiar with the block diagram. So you practice this diagram once in your notebook, rough notebook. You take one rough note and you just practice the block diagram of TDM. Then you can explain the concept very easily. So here the message signals are available, 1, 2 up to n number of message inputs are available. So each message is given to one low pass filter. This filter is called a pre-alias filter. Okay, what is the function of this pre-alias filter means? It will remove the frequencies which are non-essential. For example, this is your message 1. To represent this message 1, some band of frequency is used. Some other frequencies may also come into the filter. So it will remove the non-essential components which are not at all a necessary one, and it will transmit only the essential frequencies which are used to represent the message signal 1. Similarly for 2 up to n messages. Very simple. This low pass filter is a pre-alias filter. It will remove the non-essential frequencies of the incoming signal and it will allow only the essential frequencies which are required to represent the particular message signal. Output of these low pass filters are then given to the commutator. So what is the commutator means? It is the electronic switching circuitry. So what it will do? It will take the sample of first input and it will give to the PAM modulator. Then it will take the sample of second input and it will give to the modulator. Then third sample, fourth sample up to n input message signals sample. So it will take the sample. How it will take the sample means based on the sampling theorem. For example, if it takes the message input 1, it will take the first sample and it will send to the next stage, and after the sampling interval TS, it will take the next sample. Okay, so it will sample the each and every incoming signal as per the sampling theorem. Okay, so here you are familiar that sampling theorem, Fs. What is meant by sampling theorem means the sampling frequency Fs must be greater than or equal to twice the maximum frequency of the incoming signal. So as per the sampling theorem, the samples are taken from each input. Okay, so this is the electronic switching circuitry. It will take the sample from each input based on the sampling theorem. So here at what rate the signals are sampled, you consider only the first message. Here it performs the sampling rate, the sampling frequency is Fs, which is greater than or equal to 2 omega, and this omega is the cutoff frequency of your pre-alias filter. Okay, so Fs is the sampling rate. Then what is the sampling interval? Ts is the sampling interval, which is equal to 1 by Fs. Okay, for first message it will take the first sample, second sample, third sample, fourth sample. Between first sample and second sample, the spacing is Ts, sampling interval. In this gap, second message signals pulse will be placed here. Okay, next third. Likewise, within this sampling interval, pulses of the other message signals are placed. Okay, this is the concept. So after this, the commutator will give the multiplexed signals to the PAM modulator. So this PAM modulator will convert the multiplexed signal into a form which is suitable for transmission in the communication channel. So this PAM concept is a separate detailed concept. Here you can just explain this converts the incoming multiplexed signal into a form which is suitable for transmission in the communication channel. Okay, so here in this communication channel, n message signals are transmitted. Each signals are sampled as per sampling theorem. So here the sampling interval between the pulses of same signal. For example, first input means what is the sampling interval? Ts. Second input means what is the sampling interval? Ts. N sampling interval Ts. For the same message signal, spacing between the pulses are Ts, but the spacing between the adjacent samples is Tx. Okay, so here you consider sample of pulses of the first message signal. So this is your first message signal. Spacing between these two is Ts, sampling interval Ts. So 1, 2, 3 all are pulse signal of the same signal. In between this time period, you will place the sample of second signal. So now what is the spacing between adjacent samples, adjacent pulses? This is Tx. Okay, adjacent pulses of the same message Ts, adjacent pulses of the samples of the different message is represented by Tx. Then what is the relation between these two? Tx is equal to Ts by n. Okay, here the bandwidth expansion factor is n because n signals are sampled. Okay, and n samples are transmitted. You just write the relation. You know what is Ts, what is Tx, and what is n. Then the signal is received at the PAM demodulator. Here the reverse operation of the PAM modulator is performed, and then the signal is given to the decommutator. So here you will get the several pulses, and each pulses are given to the corresponding output. Pulses of all inputs 1, 2 up to n signals will be demodulated here, and here you will get a sequence of pulses, and that pulses are distributed to the each and every low pass filter. This filter is called a reconstruction filter, right? So how it will send the pulses correctly? Here you are getting one pulse, it belongs to message signal 1. How it sends correctly to the first filter? If the message is belong to the second input, how it sends the pulses to the second low pass filter? All because of this synchronization. The commutator and the decommutator are synchronized. Okay. Next. Now you are all familiar what is the function of this TDM block diagram. You are having message input. Each input is given to the low pass filter. This low pass filter is called as a pre-alias filter, which removes the non-essential frequencies, and then it is given to the commutator, which is a electronic switching circuitry. This commutator will perform sampling of the incoming signal as per sampling theorem. Okay, then the multiplexed signal is given to PAM modulator. It converts the multiplexed signal to a suitable form for transmitting in the communication channel, and then at the receiver side the signal is demodulated, and here you will get the sequence of pulses, and that are distributed to the corresponding reconstruction filters with the help of decommutator. Okay, now what is the advantage? Many signals are transmitted in the same channel just by sharing the time. Now what is the drawbacks available in this concept? Here at the receiver side, the received signal will have variations in amplitude and phase. Okay, so here it leads to the variations in amplitude. Otherwise you can tell it as there is a dispersion in amplitude and dispersion in phase. How this can be eliminated? Receiver side there is a dispersion in terms of amplitude and frequency. So and phase. How these two can be eliminated? Just by providing equalization of amplitude and phase. Okay, so we are providing equalization of amplitude and phase to eliminate these problems. Okay, next we will see the waveform of a TDM signal. So this diagram is very important. You explain in one particular order, then next you draw the diagram and you explain the concept. So this is the waveform representing the TDM for two message signal. So this first one, green color, is the first message, and this blue color line is the second one. So you see the first one, green color line, first sample, second sample, third, fourth, fifth, sixth, seventh, 8th. So this green color shaded is there, no? Green color shaded pulse. So these pulses are belong to the first message. So first message, this is the first pulse, second pulse. Okay, here you see between the first pulse and second pulse, they are placing the pulse of the second message signal. Okay, for one signal several pulses will be there. Between the pulses, the pulse of another signal will be placed. So here you see these two are the pulses of the first message. it is the pulse of the second message. Okay, here you see between this pulse and this pulse they are placing the pulse of the second one. Likewise, they are placing the pulses of other message signals in this sampling interval. So this interval is between first and second pulse. What is the interval means? It is TS. And the interval between adjacent pulses, it may be from message 1 or it may be from message 2. That adjacent pulse spacing is TX. Okay, that's all. Hope you understood this diagram, right? You just draw two signals. First you draw the pulses for the first signal. Then in between you draw the pulses for the second signal. Then you will get this TDM waveform. Okay. So if you are having any doubt, just post in the comment section. We will try to help you. Okay. Thank you very much.